This lesson shows how to solve linear systems by elimination. In a previous lesson, you learned to solve systems by substitution, but it wouldn't work very well in this case. For example, if you solve the first equation for x, you would get an expression with a fraction, which would be difficult to substitute. So, back to the linear system. Notice, if you add the two equations together, the y variable is eliminated, and you can quickly solve for x equal 3 by dividing both sides of the equation by 8. Then substitute x equal 3 into the first equation and solve for y. To do this, multiply 3 times 3 for 9, subtract 9 from both sides, and divide by 2 for y equals 2. And you have a solution to the linear system. This method for solving a linear system is called elimination, but it's not usually so easy. In this example, notice the x variable can be eliminated since 6x is a multiple of 3x. If you multiply the second equation by -2, you get -6x. Add them together, and the x variable is eliminated. That's the general strategy. Here are the details. Starting with the second equation, multiply both sides by -2. Then add to the first equation, and the x variable is eliminated, leaving -2y equals -8. Then divide both sides by -2 to solve for y equals 4. To find x, you can use either of the original two equations. So use the second equation, since the coefficients are smaller. Substitute y equals 4. Then 3 times 4 is 12. Subtract 12 from both sides for 3x equals 3. Then divide by 3 for x equal 1. So the solution to the linear system is 1, 4. Remember to always check the solution in both of the original equations. In this example, both equations must be changed in order to eliminate a variable. The strategy will be to change 4y and 5y to 20y and -20y and eliminate the y variable. To do this, begin by multiplying the first equation by 5 for 10x plus 20y equals -20. Multiply the second equation by -4 for -12x, -20y equals 12. Notice that the first equation has 20y and the second equation has -20y. When you add the equations together, the y variable is eliminated, and you have -2x equals -8. Divide both sides by -2 to get x equals 4. Next, substitute x equals 4 into either of the original equations. For this example, let's use the first equation. Substitute x equals 4, and you get 8 plus 4y equals -4. Then subtract 8 from both sides, divide by 4, and you get y equals -3. And the solution to the linear system is 4, -3. Remember to check the solution. When you use the elimination method, develop a strategy to eliminate whichever variable is the most convenient. In the first example, one equation was changed. The second equation was multiplied by -2, so that when the equations were added together, the x variable was eliminated and you solved for y. In the second example, both equations were changed. The first equation was multiplied by 5, and the second equation by -4, so that when the equations were added together, the y variable was eliminated, and you solve for x. This lesson showed how to solve linear systems by the elimination method. This method is also called addition or linear combinations. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.